Hey everybody, welcome to our next video all about the mole. So hopefully you remember a lot of mole conversions from Chem 1. I know if you had me, we did lots and lots of mole conversions, and I hope you did no matter which teacher you had. So let's just go ahead and review what moles are. So of course, a mole is a unit of measurement in chemistry. And this unit of measurement measures the amount of something we have, the amount of a particular element, the amount of a compound, the amount of a substance. And 1 mole of something contains 6.02 times 10 to the 23rd of that thing, whatever it may be. And we call that Avogadro's number. The reason why with mole conversions we have such a large number is because atoms are so small. So we need a massive value to represent how big a mole of something is. A mole is very similar to the word dozen, whereas if you go to Dunkin' Donuts and you say, I want a dozen donuts, they know you want 12 because that's literally what a dozen is. A dozen is 12. And of course, when we're converting to the number of particles that something is comprised of, the mass of 1 mole of something also varies depending on what substance that's in question. For example, you go to Dunkin' Donuts and you order a dozen glazed donuts versus a dozen Boston cream-filled donuts. A dozen is 12, so if you consider both of those, you have 12 of each. However, the mass of both of those is very different, and that's because glazed donuts and Boston cream-filled donuts are made up of different things. So the mass of 1 dozen of each of those is different. In the same way that if I have 1 mole of hydrogen versus 1 mole of carbon, you have the same number of each of those atoms. There's 6.02 times 10 to the 23rd of each, but the mass of 1 mole of them is different. That's because carbon has 6 protons in the nucleus, while hydrogen has only 1. So their molar mass is different. So when we're doing mole conversions, there's 2 values we have to keep in mind. We have to keep in mind Avogadro's number, which states that 1 mole of anything contains Avogadro's number of things. And we also have to keep in mind the molar mass. And the molar mass is what's on the periodic table, for elements at least. And that tells us what is the mass of 1 mole of an element. And of course, we can calculate the mass per 1 mole of compounds by just adding those together. Rather than talk about this more, I think it's best to just go ahead and do some examples together. So when we're doing mole conversions, we do need to use 2 different values as conversion factors. And you can find those conversion factors here in this little thing that I normally use with my Chem 1 students to kind of show them how to convert in and out of grams and moles and particles. If you are converting from the number of grams to the number of moles, you do need to use the molar mass as a conversion factor. And that molar mass we can find on the periodic table. And it's different for every element, which is why we always have to have a periodic table very handy when we're doing mole conversions. That second value that we have to keep in mind is Avogadro's number. And Avogadro's number states that 1 mole of anything contains 6.02 times 10 to the 23rd. You can use this if you want, but I would highly recommend actually learning how to do each of these because, like I've mentioned before, mole conversions is a very important skill that you need to know all throughout Chem 2. So what is the mass of 1.366 moles of NH3? I like to set up a little crosshair. If you had another teacher, you might have done multiplication signs, or you might have done parentheses. Ultimately, it doesn't matter the method that you use as long as we all get the same answer. I'm going to bring a number 1 down here, and that 1 just acts as a placeholder. I just don't like to leave that empty. Whatever unit is up top, that's the unit I have to put on the bottom of my next conversion factor. And that's because mathematically, these units of moles will cancel. So let's take a different color pen here. When you divide moles by moles, you can cancel that out. And we're going to put down whatever unit we want to convert to on top. In this case, it is the mass, which of course is in units of grams. So the relationship between moles to grams. Notice we don't care about the number of individual particles. What we care about is the mass of 1 mole of ammonia, of NH3. So we have to calculate the molar mass of this substance because I'm going from the number of moles to the grams, the mass in grams. Now, unfortunately, I can't look on a periodic table and find this and just copy it down, but you do have to calculate this. So let's go ahead, and I'm just going to do that up here. I'm not going to do this every time because I want you to become familiar with just kind of typing this in on your calculator. Nitrogen's molar mass is 14.01, and hydrogen's is 1.01. I'm going to multiply each individual atomic mass by the number of atoms in the actual molecule. So if I look at the formula, this formula has only 1 nitrogen. So I'm going to multiply the molar mass of nitrogen by 1. And then I'm going to multiply the molar mass of hydrogen by 3 because, of course, there are 3 hydrogens there. And my final answer is 17.04. And the units for molar mass are always your grams per mole. So that means that 1 mole of ammonia has a mass of 17.04 grams. You have to make sure you plug these in next to the correct units because otherwise, if not, unfortunately, you will get an incorrect answer. In order to solve this, you should multiply straight across. So I just grabbed my calculator here. 1.366 times 17.04 gives me this crazy answer. However, we do have to adhere to significant figure rules. This first value has 4 significant figures. This value also has 4. And we are, in fact, multiplying. So my answer should also have 4 significant figures. The answer should be 23.28 grams of ammonia. You do not have to write out the actual formula here. I only recommend that when we get to the next unit, when we are dealing with equations and we have to convert between different compounds. But in this case, you don't have to write the formula for it. 2, how many moles is equivalent to 3 grams of boron tribromide? So I have 3.00 grams of BBr3. 1 is a placeholder, always goes down below. Whatever unit's up top, I'm going to bring down. And again, mathematically, that allows for grams to cancel. And we can convert moles of BBr3 on top. So we still don't care about the number of individual particles. We don't need to calculate how many molecules this is. And it's a molecule, of course, because it's more than 2 atoms that are bonded. So we do, again, need to calculate the molar mass. So we have to look on a periodic table. Boron's molar mass is 10.81. And bromine's molar mass is 79.9. We do have to consider, however, that this molecule does have 3 bromine atoms that comprise it. So 79.9 times 3, you could just type this in on your calculator. And there's only 1 boron, so there's a glare there. So I'm just going to add the 10.81. And I found a molar mass of 250.51. That means that 1 mole, notice 1 goes next to moles, of boron tribromide has a mass of 250.51 grams. As of right now, this will not be true in a couple of weeks, but you will always have a number 1 next to the unit of moles, always, always. And then in this case, my value is on the bottom, so I'm going to divide. 3 divided by 250.51 gives me a final answer. I do need to round that to 3 significant figures. And this is a tricky one because I have to chop it off right there where that 9 is. But that 7 rounds that 19 up to a 20, essentially. So your answer is 0.0120 moles of BBr3, boron tribromide. An unknown substance contains approximately 3.974 times 10 to the 22nd particles. We want to know how many moles of particles is this? And just because it says unknown, it doesn't mean we can't do it. We can, in fact, do this problem because we don't need any other information. Whatever unit is on top, I'm going to bring that down. And now we want to know how many moles that is. So let's convert that to moles. 1 mole of anything. 1 mole of anything contains Avogadro's number of things. So in this case, we are going to use Avogadro's number as a conversion factor. It's not asking us for the mass. So we don't need to calculate the molar mass. We can't do it anyway because we don't know what this substance is. So all you need to do here is divide your first number by Avogadro's number. Now here is how you would type this in your calculator. So you need to type this in a very specific way, and that's using parentheses. So you want to put a parenthesis around this first number, and then a parenthesis around that second number. So I'm going to type parenthesis 3.974 times 10 to the 22nd power, and I'm going to close my parenthesis. Then I'm going to divide by Avogadro's number, but you need a new parenthesis there. 6.02 times 10 to the 23rd. Close that parenthesis. And there is your answer right there. We should have 3 significant figures in our answer because actually Avogadro's number is in fact a measurement. And we have 0.0660 moles. If you don't use the parentheses, what happens is the calculator is going to do order of operations, and you will most likely get the incorrect answer. What happens for most students is these exponents get multiplied instead of dividing by one another. So you get a really big exponent. Try D. So D is very similar. Pause this video, do this one on your own, and once you think you have it, come back and restart. Your answer for D should be 2.1 times 10 to the 19th molecules. This does in fact have 2 significant figures, so you should adhere to that rule at the very end. Notice I canceled out this one by accident. I should have canceled out this mole on the bottom. This one should not have any type of line through it. I apologize for that. But there is your answer. Also note that you must have parentheses around these numbers when you type them in the calculator. If not, you do get the incorrect answer. If you do have the correct work, but the answer is wrong, I can guarantee it's just typed in the calculator incorrectly. Let's try E. What is the mass of 5.00 times 10 to the 21st formula units of nitrogen gas? Actually, don't know why. Your packet might say molecules, and that is the correct value. I don't know why mine says formula units, but that should be a molecule. Those are for reasons we talk about later. Should be a molecule. So we want to know, what's the mass of this? We don't have a direct conversion from the number of molecules to the mass. In chemistry, the mole is what relates everything to everything else. It is so crucial in so many problems. So I'm going to put my 1 as a placeholder down here. And let's convert molecules. But we're going to convert that to moles because we know how many molecules are in 1 mole. Avogadro's number states 1 mole of anything contains 6.02 times 10 to the 23rd of that thing. So in this case, your units of molecules have canceled out. We're still not in the correct unit. However, we want our answer in units of grams because it's asking for the mass. So I need to continue this dimensional analysis problem and convert the number of moles to the mass in grams. So whatever unit is on top, let's go ahead and bring that down because, again, mathematically they cancel. So I'm going to use a different color here. Cancel out moles and convert that to grams. 1 mole of nitrogen. So again, always a 1 next to moles at this point in your mole converting career. Has a mass of 28.02 grams. Notice that the formula is N2, so it's nitrogen's molar mass 2 times. And then you just have to make sure you type this in the calculator correctly. So I have to divide by Avogadro's number and then multiply by the molar mass. So let's go ahead and do that. 5.00 times 10 to the, double check our exponent, 21, close. Divide that by, new parenthesis, 6.02 times 10 to the 23rd. Close that parenthesis. I'm going to press enter. Now that's the number of moles. So now let's multiply that value by 28.02. So times 28.02. There is your answer. Should be expressed to 3 significant figures because this value has 3, and so does that one. So you should have 0.233 grams of nitrogen. You try F. F is the same thing as E. It's just backwards. So go ahead and try F. And there is your answer for F. So 8.96 times 10 to the 20th formula units. Be careful with finding your molar mass for this one. So in this case, it might be easier to write down the list and then go from there. So nickel's molar mass is 58.69 grams per mole. And there's only one of them because there's no subscript after that. Nitrogen's molar mass is 14.01 and oxygen's is 16. What this is saying is that you have two of these NO3 groups. You have two nitrate groups. So if I write NO3 down 2 times, you have 2 nitrogen atoms. And I have 3 groups of 2 is 6 oxygen atoms. And the total of all of that should give you the 182.71. So I'll just do this and then I'll go over to there. Another thing to keep in mind, remember when you're doing this, particles can be many different types of things. Particles could be atoms, particles could be molecules, particles could be formula units, particles could be oranges or unicorns. It doesn't matter. 1 mole of anything contains 6.02 times 10 to the 23rd of that thing. So as of right now, these problems will not get more complicated than what we were doing on here. So give the worksheets that I sent to you a try. If you have any questions, please email me, stop by and see me. Check your answers with the answer key. Otherwise, I hope you guys are having a great day. I hope you're getting ready to go for chemistry. I always get so excited this time of year because I get my chemistry 2 students. Anyway, I will see you in the next video. Bye.